Okay, so when we look at differentiation, there's actually rules that we can do. So we've so far connected that we can take the limit of a difference quotient and work through a problem. So if we want to find the derivative of, let's say that y equals x squared, and I want you to find y prime, okay, which is the derivative of y. Okay, so when we do this before, we took the limit of the difference quotient. So the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so then we fill in all of our values. H is approaching 0 as f of x plus h, which is going to be our function with x plus h plugged in, minus just our function, which is x squared, all over h. Okay, so then we would take the limit as h approaches 0. We're going to simplify this out by multiplying it out. So we get x squared plus 2xh plus h squared minus x squared. If you have questions about how I combine this, I did skip a step. I combined, when I FOILed it out, I had x plus x times h plus x times h, which is 2x times h. So if you need to do out each step, then that's fine. And then we're going to simplify this. The x squared's canceled, and then we're going to factor out an h out of the top. So moving a lot faster now because you should have a whole assignment of this back behind you where you understand it a little bit better. So then we'll have 2x plus h. And so the limit as h approaches 0 of this is equal to, we're going to plug a 0 in for h, so the whole thing is equal to 2x. Okay, and so that was using the difference quotient. As we go through, find the limit to find what the slope is of the function x squared. Okay, so any point on this graph, x squared, the slope can be given by plugging your x coordinate into the function 2x. So if I want to know what the slope is of the graph at 5, then if I plug it in here, then I know the slope is 10 at x equals 5. Okay, so hopefully we're starting to make those connections that this is a function that gives us the slope at any point of the graph. Okay, now what we're going to do now is we're going to go through some rules that will help us so that we don't have to go through that whole process. So, using rules, if y equals x squared and I want you to find y prime, you'll be happy to know that it's as easy as saying y prime equals 2x. And that's actually all that you need to do, because I will teach you the rules that, that get us from x squared down to 2x. Okay, so the first rule, so these are going to, you want to make flashcards of all of these. You will definitely be memorizing all of these to be able to use them often now. So. Okay, so the first rule is what's called the constant rule. Okay, so if you have a constant, then, and you want to take the derivative of it. So we take the derivative of a constant, we're going to call that constant, I think I'll just call it c. So if I want to find the constant c, this is always just equal to 0. Now let's think about what this means. It's saying, what is the slope of c? Let's say that c equals, I want the derivative of 5. Well, what is the slope of the line y equals 5? Well, y equals 5 is a horizontal line. Well, the slope of that line is 0. So that would just always, no matter if it's a constant here, it'll always be 0 because it's a horizontal line, and that's, yeah, so that one's a simple one. And then we have, the next one is a constant multiple. Okay, and a constant multiple is saying, okay, if I take the derivative of c, a constant next to x there, then it'll just, see, they do c of u. So pretty much if we have, the derivative is just going to be just the constant. So for example, if you have, if I want to find the derivative of 3x, okay, so think about what the line 3x looks like. Okay, it goes through 0, 0, and it has, I can actually draw it right here. It goes through 0, 0, and it has a slope of 3, right? It goes up 3 and over 1. Up 3 and over 1, okay? So it has, so if you're asked to find the slope at any point of something that looks like this, well, we already know from the form y equals mx plus b that this is the slope of the whole function. So you see how when you take the derivative of 3x, the slope will always be 3 because it's a linear function that has that same thing. All the time, it's always increasing at a rate of 3. Okay. So it's just trying to connect that, what the graph is actually looking and what you're asking for with differentiation. Really, all we're asking for is the slope of the graph. So with lines, that's easy to do. So let's see, the next one that we're going to talk about is called the sum or difference rule. Okay, so if you have a sum or a difference, you can actually take the derivative of each of those separately to find that, or you can add them together first. So, for instance, if I'm going to take the derivative of u plus or minus v, then it would just equal the derivative of u plus or minus the derivative of v. So an example of that would be if I wanted to take, if I want to know what is the derivative of 3x minus 2x. Okay, now obviously this is something that you could combine together first. So let's do two different ways. So the first way we could solve it is we could say, well, we're going to take the derivative of x, which just equals 1. Okay, because do you see how this is, x has a slope of 1 all the time. Okay, the other way that you could do it using the sum or difference rule is saying, okay, I'm going to take the derivative of 3x, which is 3, and the derivative of 2x, which is 2, and then I'm going to do 3 minus 2 equals 1. Okay, so basically, and that'll make more sense as you start doing derivatives more. When you're adding and subtracting, you can take separately the derivative of each of the function's pieces that are added and subtracted together so that you don't have to always simplify. So we're going to actually skip products and quotients. We're going to do that next time. So just know that if you're multiplying together two functions or dividing two functions, that it actually is a little bit more work, not much more, but it is enough that we're going to do that next time. Okay, so we're going to skip over those for right now. Okay, let's look at just what a simple power rule. Okay, so a simple power rule says that if you take the derivative of a function, let's say x to the n, okay, so it's a power, it has a power to it, then the answer is just going to be, you pull down the exponent, you subtract 1 from it. So it's going to be n, so you pull it down, so you have n in front of it, and then you subtract 1 from the power. Okay, so an example of this is just the example we did actually at the beginning of the lesson. If you want to take the derivative of x squared, then you would take this 2 down in front of your function. You keep your x there, and then you subtract 1 from your power. So then it would be x to the first power. Okay, so let's look at another example. What's the derivative of x to the 5th? Okay, so if we're doing x to the 5th, you bring the 5 down in front, and then you subtract 1 from your power. Okay, so it would be 5x to the 4th power. And that's for just what they would call, what is called the simple power rule. Now the only difference now is that, and actually we're going to talk about the chain rule more later also. So let's just do another little example of combining two of the ones we've just talked about. If I want to find the derivative of 3x to the 4th, okay, because that constant is just out in front of there, you actually still do the power rule the same way and kind of leave that 3 alone. So I'm going to leave the 3 and I'm going to multiply down by the 4 and then raise this to 1 power less than what it was. So this gives me 12x to the 3rd power. Okay. Now if you look at it in comparison to just the constant multiple rule that we talked about, it really was leaving the constant there anyway. And it's like using this. So for instance, if I have 5x, the power of this x is 1. And so I would bring the 5 stays here, because then the 1 comes down, and you would do 5 times 1. And then you would have x to the 0 power. Well, 5 times 1 is 5, and x to the 0 power is equal to 1. So you still have 5 times 1, which is just 5. So hopefully that helps connect it. But yeah, look over those examples again, or rewind and watch that example again, especially this one, if you have any questions on that. But as you do it, it will come pretty easy as you do it multiple times. Okay, so I'm going to take now, we'll go over product rule, quotient rule, and chain rule a different time. So right now we're just going to do the basic simple ones. I'm also going to throw in some that are just memorization. So there's derivatives that you have to memorize. And these are ones so we'll start out with exponential derivatives. Okay, and you can apply these same rules using those, but you do have to know what some of those rules are. So the derivative of e to the x is equal to e to the x. Okay, so that's one that it causes a rotating effect, a cyclic effect, because the derivative is just the same as what you start with. But it is one that you just have to memorize. Okay, another one is, we'll look at a logarithmic. So you'll want to make flashcards of all of these. So the derivative of, let's see, this one has natural log. We'll start with natural log and then I'll look up the other one too for you as well, sorry. Let's see, so the natural log of x. The natural log of x is equal to 1 over x. Okay, and then the derivative of log is a little bit more complex, but not too bad. Just mostly if you memorize it, is the log base b of x is equal to 1 over x natural log of b. So natural log right there. Okay, so definitely flashcards, so you can go through and practice these. And so as we have flashcard quizzes, you're ready to ace it. So the next thing is trigonometric functions. Okay, so trig functions also are memorization that we have. If you have the derivative of sine is equal to the cosine of x. So interesting that they're inverses of each other and that there's the derivative of sine is cosine. But you have to be careful because the derivative of cosine is equal to the negative sine of x. Okay, so you have to be really careful with those signs. Okay. The derivative of tangent is equal to, the tangent of x is equal to the secant squared of x. The derivative of cosecant of x is equal to negative cosecant x cotangent x. Sorry, got kind of tight on that side. The derivative of secant x is equal to secant x tangent x. That's an x right there. And the derivative of cotangent is equal to negative cosecant squared x. Okay, so there are little patterns in there to try and memorize them. But they're a little tricky. So as you go through, make sure that you're really practicing those flashcards. Okay, and then also we have inverse. So the derivative of an inverse function. Actually, let's do inverse trig real quick. Just so you have them and you have a flashcard made for them. Let's just do the derivative of inverse sine of x, which is u prime over square root of 1 u squared. I'm trying to think if there was other ones. We'll just do the three main ones. Okay, and then the derivative of the inverse of cosine x is equal to negative, sorry, this I have u's on here. This will be 1. Sorry, I'm not doing these u's yet because until we learn the chain rule. So 1 over 1 minus x squared, and this one would be negative 1 over the square root of 1 minus x squared. And then you have the derivative of tangent inverse, which is equal to 1 over 1 plus u squared. Okay, and I think the biggest thing is recognizing, and this is an x again, I'm sorry, is recognizing when you see that, especially like something that looks like that you can kind of look back and say, okay, I think that was an inverse trig. And really that's the biggest reason that I want you to have them on flashcards, is just to be familiar with them and be able to see them and know. Okay, so let's look at an example of using some of these rules and how it's useful. So, a derivative can be used to find anytime you're talking about the slopes of problems. So it can be useful in finding horizontal tangents because there's a horizontal is when the slope would be equal to 0. So a horizontal, is this direction. Okay, and we're going to learn a lot, we're going to talk a lot about why that is important to find anywhere where it has a horizontal tangent. So those tangent lines, when that's when the slope equals 0. So horizontal and this is where slope equals 0. Okay, and we're going to go through a lot of this and how we use it. But right now, let's just say, so we can find the horizontal tangents. Of y equals x to the 4th minus 2x squared plus 2. Okay, so we're not going to really talk about the whole application yet necessarily, but let's first show that we can find anywhere where it has a tangent that equals 0. So we start by finding the derivative, because the derivative is going to tell us all the slopes. So the derivative of x to the 4th, you use the power rule, bring 4 down in front, and subtract 1 from your power. Then you have minus 2x squared, so you bring your 2 down in front, you get negative 4x, subtract 1 from the power, gives us 1. And then the derivative of 2 is equal to 0 based off of that, the constant rule. Okay, so now we have the derivative, and I want to know when the slope or the derivative equals 0. So I'm going to set this whole thing equal to 0. Okay, so this is saying, when does y prime equal 0? Now notice that to solve for this, we need to factor this out so that we can set each of our factors equal to 0, which is an algebra concept as well. So we're going to say, okay, 0 equals, they both have a 4x in them, so we take 4x out, and we're left with x squared minus 1. So now that we have two factors, we can set each of those factors equal to 0. So 4x equals 0 and x squared minus 1 equals 0. Okay, so I divide both sides by 4, I get x equals 0. And then I'm going to add 1 to both sides, so I get x squared equals 1. Therefore, x equals, anytime you take the square root of both sides, it's plus or minus 1. So the slope is 0 at x equals 0 and plus or minus 1.